Discussed voltage stability assessment techniques. In that we discussed VIP and singular value decomposition, bifurcation, configuration, continuous power flow, and energy function. Let's see the flow chart of how exactly the power will be flowing, how exactly voltage stability analysis technique is executed. Right. First one is a start button, start. Then there is a configuration of system. So it would be configuring everything in the power supply system and fault simulation. If suppose voltage stability analysis of it depends upon it may make a constant voltage if suppose fault occurs also. If suppose supply is 230, if suppose fault occurs in the power supply system, what happens? So automatically it goes to zero, and then again if you reconnect, it may constant voltage whatever before we are getting, right, that voltage will be flowing. So that also will be there in the fault simulation. And next is the system power system smart. So in this if suppose if you make a smart technologies and then a sensor based operations, so just we consider if it is a smart grid or existing grid. So that is the question mark. If suppose not a smart grid, definitely it goes to again a configuration of system, again it would be changing, right? So next is a contingency studies. So what are the contingencies occur in the possible system? What are the um, uh, power supply enquiries, and then what are the power supply methods we have to implement, that goes to here. And system stability analysis. So if suppose everything is good, and then everything is based on the procedure, definitely it goes to system stability analysis operation. And then it may gives output as a constant. Next have the we have voltage stability indexing. So many indices characterizing the proximity of an operating state to the collapse point have been developed. The degeneracy of the load flow Jacobian matrix is used for an index of power system steady state stability. So here we are going to use Jacobian matrix for solving the problems, or Jacobian matrix is for executing the overall system. So we are going to discuss now. And analysis techniques for steady state voltage stability studies. Is there early stages voltage collapse studies mainly concern steady state voltage behavior. Voltage collapse is often described as a problem that result when transfer limit exceeded. So in the analysis technique, if suppose planning expansion or extension in the power supply system. So uh, some of the techniques, if suppose voltage collapse will be occurring, so at the less interval of time it will be um, making a stable operation. Voltage collapse is often described as a problem that results whenever transfer limit is exceeded. So it's a often occurring collapses in the power system supply. So that also this technique analyzes and expand and then extends, and then it may resolve the problems, right? Next, application and implementation of plans of voltage stability. See here, consider the power flow equation. Define the equation below. The vector diagram, vector function f is constant and n is a scalar equation defining curve in the n plus 1 dimensions x lambda space. Continuous means tracing of this curve, right? For the convenient graphical representation of previous solution, already we have given this diagram and then solutions also. We need one dimensional measure of x, and the frequency used measure of measures are xix, where n is equal to sigma is equal to 1 I2 square of the Euclidean norms, and then xxi n is equal to I is equal to maximum norms. So xxk for some indexes k is greater than 1 less than or equal to n, right? So optimizing stability constraints through the preventive control of the voltage stability. The controllable reactive power sources include generator, shunt reactor, shunt capacitor. See, controllable reactive power sources include, generator in the sense synchronous generator, okay, and shunt reactors also to eliminate this one uh, power flow and then power variations, shunt capacitor for to eliminate disturbances, and then to increase the power factor, and then I mean like improving the power factor. Unload tap changers of transformer OLTC. So the generator can be generator absorb reactive power depending upon the execution. When the excited, they supply the reactive power. When under the excited, they absorb the reactive power. The automatic voltage regulators or generate can continuously adjust the excitation. A reactor shunt capacitor voltages are traditionally switched on and off through the circuit breaker on command from the operator. Since early 1980s, advanced in flexible AC transmission system facts flexible AC transmission systems. Controllers in the power system have led their application to improve the voltage profiles of power networks. So, this facts and smart grid and a distributed generation control system are integration of distributed generation because of to improve the power supply system to increase the power supply, increase the power demand, and increase the power consumption. And uh, power consumption in the sense reducing the power consumption, increasing the um, like power generation, right? So that also controlling techniques are stability constraint throughout the preventive control of the voltage stability analysis techniques. So in this optimizing stability, so the name itself indicates the losses must be less, and to increase the power supply system uh, in the normal operation, normal way. So that's a concept in this controlling of voltage stability, right? So in this video, optimization techniques and voltage stability techniques, preventive actions, and also we discussed. Okay, next we'll discuss voltage stability assessment in the next video.